Good day, my fellow listeners. Here we are here to do a short video on shadow. Today we want to be looking at the term shadow. Now, a shadow is one of the effects produced by rectilinear propagation of light. A shadow is one of the effects produced by rectilinear propagation of what? Light. Now, what do we mean when we say rectilinear propagation of light? Rectilinear propagation of light is simply a phenomenon where light travels in a straight line. That is a rectilinear propagation of light. Now, listen carefully. Now, when there is an opaque, take note of that word. When there is an opaque, that is an obstruction in the direction of light, that can result in shadow. And we all know that when we talk about opaque, what is an opaque? An opaque object are objects that does not allow light to pass through them, thereby casting the shadow of the object on the wall. That is when we are talking about what? Opaque. Now listen, let's come home. What is a shadow? A shadow is an area or a region which light cannot what? Reach. A shadow is an area or a region which light cannot what? Reach. That is a shadow. A shadow is produced as a result of the obstruction of light by an opaque what? Object. Let's take for example, when we talk about example, the shadow under a tree or a canopy on a bright sunny day is a shadow produced by the opaque tree or canopy. I come again. Example. I said the shadow under a tree or a canopy on a bright sunny day is a shadow produced by the opaque tree or canopy. Now, a shadow takes the shape of the object producing it. When a shadow of an object is cast on a wall, you see the shape of the object on the wall. That is what I'm trying to say. Now, when we look here, when we talk about the sharpness of the boundary of a shadow of an object depends on the intensity of light striking the object. Are we there? Now, the darker part of a shadow, take note of this, the darker part of a shadow is called umbra, while the gray part with partial darkness, we call it what? Penumbra. Now, if I want to show you this using an example, look at what I'm trying to say. Now, if you look at this diagram, if I have this as a word, a source of light, this is a source of light, I can use this look at this. Now, if I take this as a source, this is a source of light. I can take this as an opaque. If I take this as a source of light traveling, this side as the opaque. This opaque. Why this is what? Now, if you look at this, if you look at the opaque now, look at the object here. So this dark part, this part you are seeing here now, is the darker part of the shadow. This part that is dark like this darker part, this part now, this part we call it umbra region. Umbra what? Region. While this part we call it penumbra region. So in the case when you are talking about a shadow, you must get this understanding. So if you look at this opaque object now, you can see the shape on the wall. This is the screen now. you can see that this darker part we say is umbra, which is the darkest part of a shadow. While the gray part with small dark region, we call it penumbra. So I want you to get it. So with this now, this is what we mean by shadow. So if somebody told you what a shadow is, a shadow, like I said again, I say simply an area or region which light cannot reach. That is what I call a shadow. So you must get it. So a shadow is as a result of what? An opaque object. It is produced by an opaque what? Object. That is when we are talking about what? A shadow. Thank you. That is it. Now, in this other part here, we want to continue the class by looking at the term eclipse. And this eclipse is also one of the effects produced by the rectilinear propagation of light. You must know that. And what is eclipse? Eclipse occurs as a result of a shadow cast by one heavenly body on another when they are in a straight line. Listen carefully. Eclipse occurs as a result of a shadow cast by one heavenly body on another when they are in a what? A straight line. Now here I want you to get this picture very clearly. We all know that the sun, being a luminous body, the sun gives its own light. We all know that. We agree to that. The sun gives its own what? Light. While the earth and the moon, are non-luminous bodies. That is, they are opaque bodies. We know that the moon there reflects the light from the sun. That is when you are talking about what? The moon. It does not produce its own light. It does not have its own light. It's an opaque body. Rather, it reflects the light from the sun. But now take note of this. Now listen carefully. Now the earth is a big planet. We all know this. We studied this in geography. When we are talking about the solar system. A system, the solar system is a system that contains the 9 what? Planet. So the earth is one of the planets. And being that the earth is a planet, the moon there is a satellite. And the earth is bigger than the moon. Are we there? Now, I want you to get that the earth is a big planet on its own, moving around the what? The sun. The earth is moving around the sun. While the moon is a satellite to the earth, it revolves around the earth. But you must observe this. You must know that the earth is bigger than the moon. Now, take a look at this. Now, during this movement, where the earth is moving around the world, the sun, and the moon is revolving around the world, the earth. During this movement, at a certain time, all these 3 bodies, they lie in a straight line. These 3 bodies lies in a what? A straight line. And that results to eclipse. When they are in a straight line. Now the type of eclipse obtained depends between the 2 bodies. The earth and the moon. The one that casts a shadow on the other. Now if I want to, let me show you a diagram. Let me describe this using the diagram. Now we are talking about what? The eclipse. And I said the type of eclipse obtained depends between the 2 bodies, earth and the moon. The one that casts a shadow on the other. Now if you look at the diagram on the board here, there are 2 diagrams here I want to use to describe this movement. Like as I was saying, I was talking about the sun. This is the sun. And this is what we call the orbit. This is the orbit of the earth. Why this is the orbit of the world? The moon. Now, if you look at it, The earth, as the earth, look at the earth, moving around the world, the sun. Likewise, the moon is also moving around the world, the earth. But at a certain time, when the sun, the earth, and the moon are in a straight line, the eclipse that occur, like I said, depends on the one between the earth and the moon, the one that is in one, another one shadow. What I mean is this. Look at me now. If you look at it now, in this straight line, if you look at it, the earth here is casting a shadow on the moon. Look at it. The moon now, if you look at it, this is the moon. As the moon is revolving around the earth, the moon moves into the shadow of the earth. And the kind of eclipse that occurs here, we call it lunar eclipse, which is also known as the eclipse of the moon. And when that eclipse occurs, it means that the earth is between the moon and the sun. That is when lunar eclipse occurs. So now you see that the earth is casting a shadow on the world, on the moon. Being that the earth is an opaque, it's a non-luminous body. So the light, the rays, the light from the sun can no longer get to the world, to the moon. Why? Because the earth totally obstruct the world, the moon. So now the moon, if you look at this region, totally, they experience what? Darkness. Look at it, everything here now. But now, in this kind of eclipse now, to draw this eclipse, if you look at the sun, this is the sun. Look at the sun. We have the world, the earth, we have the earth, and we have the world, the moon. So what happened when they are in a straight line? Look at it. Look at the straight line here. Look at it. We have it like this. You see it now? So along the line, look at it. This is the earth, like as I said. I'm trying to draw the diagram. Look at it. Now we have this. We have it like this. So in this case, now look at this lunar eclipse now. So what I'm trying to say, look at it here now. This is the diagram. The diagram for the lunar world eclipse. So if you look at the sun, this is the earth. Between the moon, look at the moon. Look at it. So if you look at it, this moon is in total what? Eclipse. This is total eclipse of this moon here now. Is experiencing total what? Eclipse. Because the earth is bigger than the moon now. It could it could obstruct the moon totally. So now, if you look at these people here, the people here now, this moon here now, no eclipse here. But if you look at this, part of it, there's partial eclipse here. Here now, this part, look at it, divided into two now. The people here now, there's no eclipse here, but here there's a partial eclipse. Here we call it partial what? Eclipse. We have partial eclipse here. Here is partial eclipse. Look at it. Likewise here, look at it now. All these are partial eclipse. All these are partial what? Eclipse. Partial eclipse. Why here, no eclipse? So if you look at it now, this is what we call a lunar eclipse, which is the eclipse of the world, the moon. Now, like as I said now when you come to this now, you can get this very clearly now. If you look at the earth, the moon, the sun, the moon, and they are in a straight line already now. But now if you look at this condition, the moon is between the earth and the sun. That is to say, the earth is in the shadow of the moon already here now. So now if you look at it very well, the moon, being that the earth is bigger than the moon, the people on the earth, they cannot experience total what? Eclipse. Some part of the earth will experience eclipse, while some part we have light. Now because why? Because the moon is small. Look at the area the moon could cover. The moon could cover this area, this part. This part could experience what? Darkness. Eclipse. We could experience eclipse. Not every part of it. Are you getting now? We experience it to this. So now notice this very well. Now this eclipse, as the earth is in the shadow of the moon, this eclipse we call it solar eclipse. We call it solar what? Eclipse. But this solar eclipse, they are in two types. They are in two types. So if you look at the example, if I want to draw the grid diagram on this solar eclipse now, look at it here. Look at it, this is the diagram. Now you see the sun, you see the moon, and you see the earth. When the moon is between the earth and the sun, we call it solar what? Eclipse. That is what we call the eclipse of the sun. So I want you to get this picture very well. So like as I explained, I told you that eclipse occur as a result of a shadow cast by one heavenly body on another when they are in a straight line. Now, here now, if you look at these bodies now, these are the three bodies now. Now, these three bodies, whenever they are in a straight line, eclipse is bound to occur. And I told you that within the moon and the earth, between these two, the one that is at the middle depends on the kind of eclipse that occur. Now, look at it as it is here now. Now, like here now, I was talking about the solar eclipse now. Now, let's look at another type of this solar eclipse. Another type of this solar eclipse, we call it a lunar eclipse. And lunar what? Eclipse. So look at the other part. Because I told you, I said the solar eclipse occur in two ways. Like we talk about solar eclipse, we still have another one again. It's close to the solar eclipse, but really it's not solar. We call it annular eclipse. Annular what? Eclipse. Annular eclipse occur when the extreme rays at the moon edge intersect before reaching the earth. I come again. I said annular eclipse occur as a result when the extreme rays at the moon edge intersect before reaching the earth. And in this kind of eclipse, whenever it occurs, a ring of bright light is formed around the shadow of the moon. As I can show you now, let me show you a diagram on that now. Now, when we are talking here, there's something picture I want you to get. Now look at this diagram. When we are talking about a lunar eclipse, is something like this. Now you can see that the sun, the moon, and the earth. You see that the moon is at the middle, is between the earth and the sun, just as that solar eclipse. But the difference between them is that you look at the extreme rays. Look at the extreme rays. Look at this ray. This is the extreme ray. Look at them, the last one here. Look at them at the moon edge here. You see they intersect before reaching the what? The earth. You can see the point of intersection. That is the difference between solar eclipse and this. Are you getting now? This is another part. This is another type of solar eclipse. This is solar eclipse, but this is a lunar. But the difference between this one and that one is that the extreme ray intersect. And in this kind of eclipse, a ring of bright light is formed. Are we there? Low of the what? The moon. So I want you to get this. This is eclipse. With this, now I'm assuring you, Left Light what? Academy. Remember to subscribe. I will see you in the next video when we want to talk about the pinhole camera in our next class. God bless you.